Now in the two previous video where I show examples of vector diagram, maybe parallelogram, just like if I have two forces here, you complete the parallelogram, there's the resultant, or similarly is a tip to tail method, then that will be the resultant. So, and we have been showing examples involving force, okay, how many Newton. So we can do that because all these are vector quantity, but it is not just purely for forces. As long as it's a vector quantity which contains magnitude and direction, you can use vector diagram to solve them. So I'm going to go through three questions which involve speed in a specific direction, which is your velocity. In other words, it's a vector quantity. Therefore, I can use similar vector diagram to solve them. So let's take a look at this first question. If there's no wind, the engine of the airship push it due north. That means since the direction is given here, that means to say the airship here will actually go north in this direction, and it's 20 meters per second. And now there's a wind blowing in this direction, in the west direction, which is 12 meters per second. So which vector diagram shows the resultant force R of the airship that is obtained? Now, as you know, if there's no wind, it will just go directly straight towards the north direction. But if there's a wind blowing to the left, obviously you will not continue to go straight. You will be blown to the left-hand side, more towards the west. All right, so that will be your resultant. This is something you should know. So since, like I say, velocity is just like any vector diagram, so if I just draw a point here, all right, so this is my 20 meters per second, and this is my wind. I can just bring it to this side here. So these are like two forces or two velocity that's acting on the airship. This is 12 meters per second. So the resultant force will be here. So that is your resultant force. So all the options here are using kind of like parallelogram. So the answer here will be B. Now some of you might ask, what if I choose to think of the tip to tail method? Can. So if you think about the 20 meters per second here, and the wind here, I will join to the tip, okay, join the tail of the 12 meters per second over here. And likewise, this will be your resultant R that's acting on the airship. So they are similar, okay, but since all the options here are parallelogram, okay, this will be much easier to see. In this question, you have an aircraft that heads northwest at 400 km per hour, so which is roughly around this direction. So this point here represents the aircraft, and let's start with this 400 km per hour. Then you have the wind that's blowing northwest, which is in this direction, so I can draw it here. Okay, but this is not to scale, but you roughly have to take note of the length. So 400 versus 100, so this will be about a quarter of the length. So that will be your wind direction, 100 km per hour. So if we were to complete the parallelogram, that will be the resultant velocity that's acting on the aircraft. So if you want to know the tip to tail method, so it's similar. I can actually draw the 400 over here. Then I don't change the direction, I don't change the size, so that will the tail of the 100 km per hour will join to the tip of the 400. So the resultant will be in this direction. So if you look at the four options here, firstly, let's take a look at D. This portion here is wrong because the wind is in the northeast direction, which is in this direction, not downwards, southeast. Okay, so D is definitely wrong. And let's take a look at C. The 100 is correct, the 400 km per hour is correct, but the resultant, when it's like the two winds is blowing this way, okay, so the resultant must be in this direction, okay, not this. So likewise, B will be wrong because the wind is in the opposite direction, and therefore the answer will be A. This is like your parallelogram, okay, similar to this. Now this question is a bit tricky. You're given a boat crosses a river and arrives at the point due north of its starting point. So that means to say the starting point of the boat is here. Eventually it will end up here. Just go straight due north. But you have to read this portion here carefully. You have a speed of the boat V in the still water, and there's also a wind that's present blowing from west to east. That means this is the direction of the wind that's blowing the boat to the right. And the speed, the velocity of the boat in still water, there's a V here. But you have to understand, since there's a wind blowing you to the right, in order to counterbalance and yet you still want to reach due north, that means to say the velocity of the boat has to be in this direction, somewhere northwest, in order to counter the wind, and then eventually you can end up in this position here, which is due north of your starting point. So let's draw the vector diagram here. Now let's start from a point here. That's the boat, represent the boat. There's a velocity of W that's acting on the boat to the right side here. So this A will be wrong because your wind is to the west. It's supposed to be to the east. And the next thing, you know that the boat V, the velocity of the boat V in still water cannot be vertically straight. If it's vertically straight and there's a wind blowing, eventually you will go somewhere northeast. So that will be your V. Okay, and if that's the case, you complete the parallelogram. It is only then is possible that the resultant velocity acting on the boat will be due north, just in the direction of north, going straight here. Since all the options here are in terms of tip to tail method, I can also redraw. What if I think of it this way? I start with the wind that's here, then the tip is here. I'm going to join my V. All right, my V in this direction. That's your V, and the resultant will be somewhere around here. That's your R. But then you can see that there's no option that's similar to my tip to tail method here. So I'm going to redraw it in another way. So maybe I will start with my V, which is, all these are similar. They are actually the same. So now is the tip of my V here. I'm going to join my wind, the tail of the wind to here, which is to the right hand side, to the east side, and the resultant will be here. That will be your R. So take note that these two are the same. Okay, depends on how you draw it. So now that I have this option here and it's similar to C, so therefore the answer is C.